Dew point, precipitation, clouds, and wind. This will be a review of precipitation and clouds, an introduction of wind, and additional information about dew point. So some water words first. Evaporation. Evaporation happens when water in puddles, lakes, and rivers is heated by the atmosphere and turns from liquid water into water vapor and then travels throughout our atmosphere. And as it gets higher and higher in our atmosphere, the water vapor will cool and condense and begin to form clouds. In order for water vapor to condense, it must condense on dust or salt particles. Precipitation. Hail, rain, sleet, and snow all fall from clouds due to gravity. Freezing rain, however, is not a type of precipitation, but is a result of rain and objects being too cold. So hail is usually spherical and round and drops from clouds, typically from thunderstorm clouds. Rain is water droplets. Sleet is as water droplets fall throughout our atmosphere. The atmosphere is cooler than where they fell from the clouds, so they turn into ice pellets. Snow is frozen water. And freezing rain is when liquid water or rain droplets fall from clouds, but the objects on Earth's surface are really cold or colder than the atmosphere, so the rain freezes when it hits it, and that creates our ice storms. So here are the water words: condensation, evaporation, and precipitation. So again, clouds form when water vapor condenses on dust, and when that happens, you get water droplets, and it has to happen at cooler temperatures. And the temperature at which condensation starts is dew point, and that can change throughout a day, throughout a year. Dew point happens when the air becomes saturated with water vapor. As it becomes saturated with water vapor, it can no longer hold or cause more water vapor to evaporate, so therefore water vapor starts to condense, and the temperature at which that happens is what we call the dew point. Some of you may have noticed in the summertime especially, if you wake up early and you go outside on the grass is all wet, but it didn't rain the night before. That's what we call dew, and that's because the grass was cooler and water vapor was able to turn into a liquid and condense to it. So the temperature of the grass cooled the air around it, and so the water vapor clung to the blades of grass. So any object that was cooler than the surrounding air, water vapor would cling to and turn into liquid water. So that's why the grass is wet in the summertime. When air temperature and dew point are close together, the air is really humid. And when dew point and air temperature are the same, because it's really humid, that means the relative humidity is high, and everyone feels sticky and muggy. On cloudy nights, the Earth gives back heat that it absorbed throughout the day, and at night the Earth sends that heat back into outer space, and we call that radiant heat. But on cloudy nights, clouds act as a blanket, so that heat doesn't escape into space. It is absorbed by the water in the atmosphere, or sometimes the water in the clouds, and by the water vapor. And then it keeps the ground pretty warm, so no dew is formed. So on cloudy nights in the summer, typically you're not going to find any dew on the ground the next morning. If the clouds have moved away during the night, then you may have dew. But on clear nights, when all that heat is lost to outer space, the ground cools much quickly than the air above it, and then you have that water vapor in the air that surrounds the ground will condense onto objects. Okay. Wind. As you saw the flags waving in the wind from today, wind is caused by unequal heating of the Earth's surface. And the Earth is heated unequally due to the tilt of Earth. So that brings us back to the causes of the season. So this unequal heating of Earth's surface for our large scale winds are caused by the tilt of the Earth. When you have local winds, which we'll discuss more in class, such as land and sea breezes, that's caused by unequal heating of land and water and how well they hold on to that heat. And then as they sort of let go of that heat, the difference between land and water releasing that heat. So warm always follows cold, and so we have winds, or winds also travel from high pressure to low pressure. And when that happens, we get wind. The wind can change. We can have little light breezes due to unequal heating of Earth's surface in smaller pockets or local areas, and then again in larger areas. So a difference in air pressure is what causes the air to sort of move, which we call wind, and we measure winds by their direction and speed. So an anemometer is used to measure wind speed. This is a photograph of anemometers that we have in school, and that measures wind speed. The little cups catch the wind, and then you read that scale, and that sort of red circle rises up and down and allows you to measure the wind speed. Wind direction is measured by a weather vane. And this is what a simple weather vane looks like. Many of you have probably seen them on the tops of barns, or maybe you have them on your house.